Hello everybody, today we're going to talk about graphs of tangent, cotangent, cosecant, and secant. Okay, so let's talk about the tangent function first. This is what the tangent function looks like when you graph it. Okay, so we go from 0 to 2 pi and 0 to negative 2 pi this way. So the domain is the set of all real numbers except odd multiples of pi over 2. So like 1 pi over 2, 3 pi over 2, 5 pi over 2. Okay, there's asymptotes there. So, so you've got these asymptotes every pi, but they're on the odd multiples of pi over 2. Okay. The range is the set of all real numbers. So if you just look here, just at this one section, this goes to negative infinity to positive infinity. So it covers all the numbers in the range. Not a problem. The tangent function is odd. So if I took this thing and I rotated it 180 degrees, the graph would look exactly the same as it does now. So it's an odd function. It's periodic with a period of pi. So if I look here, blue. So here's one period, gets all its values in between there. This is a half a pi, this is a half a pi, so this period is pi. And then it just repeats itself. The x-intercepts are at negative 2 pi, negative pi, 0 pi, pi over 2. So every whole pi, you get the x-intercepts. And there are vertical asymptotes everywhere it's undefined, so that's the odd multiples of pi over 2. There's vertical asymptotes there. Okay, so there's your tangent function. Now, cotangent, very similar to tangent, right? Except it's flipped the other direction and it's shifted this way, pi over 2. Okay, so the domain is the set of all real numbers except multiples of pi. So here's where I have my... here's where we have our asymptotes, or the multiples of pi this time. So at pi, at 0, at 2 pi, negative 2 pi, we got asymptotes there. The range is the set of all real numbers again, because it goes from infinity to negative infinity. The cotangent function is odd. So again, if I rotate this around the origin 180 degrees, I get the same exact graph. It's periodic with a period of pi. So again, if I look at this distance right here from 0 to pi, I get all of my answers. So there's the period. And the x-intercepts are the odd multiples of pi over 2. So it's pretty much the same as tangent, except you shift the zeros and the asymptotes. Okay, let's look at cosecant and secant. So here's cosecant. And I always like to kind of look at the sine and the cosine when I have a secant and cosecant. So the sine would look like this. And so you can really see, if you do this, you can really see that this, the cosecant, is a reciprocal of this. So here the value is 1 for both of them. Okay, and here as this gets smaller, this gets larger. Here where it's 0, I have an asymptote, and it's because it approaches infinity. So, I've got asymptotes here, and here, and here. Everywhere that sine is 0, I end up getting an asymptote. Okay, and the same thing over here with secant, because if I draw a cosine on here, cosine looks like this. And so you can really see that the secant is the reciprocal of that. Okay, use transformations to graph the following. Hey, negative cotangent. All right, so when you do a transformation, I need you to show all the steps, so you're going to need some colored pencils. I usually like to draw with a lighter color, the original. So cotangent would look like this. And then I go ahead and label it. So this is cotangent of x. Then I'm going to come back and do the negative cotangent of x. Well, that's just going to flip this upside down. So this is going to go like this. And I almost always use my final transformation in red as my final answer. And there's my negative cotangent of x. Okay, cosecant of 1/2 x. All right, let me give you a little trick here. When you're doing cosecant and secant, I always start with sine or cosine. Okay, so sine would look like this. All right, so there's my sine. Okay, now, in here, this changes the period. Okay, so remember that the period of sine is 2 pi over w. In this case, my w is 1/2. So that means that the period is going to be 4 pi. Okay, so what I'm going to do, actually, let's do this so we can get a good color coordination here. Let's make this, okay, so what I'm going to do now is I'm just going to change the period here, and I'm going to go change this. This is now, my period would normally go from 0 to 2 pi. I'm going to make this 4 pi, which would make this 2 pi, which would make this pi, which would make this 3 pi. I'm just going to change the scale. That way I don't have to redo the graph. Okay, so now this thing is now sine of 1/2 x. And now I can go ahead and switch it to cosecant. So cosecant is going to look like this. It's going to have asymptotes everywhere that this one's 0. It's going to look like this. And then that's going to be cosecant of 1/2 x. And I'm done. I think it's way easier to do my transformations on sine than it is to do it on cosecant. Okay, so I'll do all those on sine, and then I'll take the reciprocal and get the cosecant. Okay, so do the transformations on negative 2 tangent x plus pi over 4. So we'll start out with tangent. Tangent looks like this. Okay, so we'll put our tangents in here. So there's tangent. Okay, now pi plus pi over 4. So pi over 4 is going to shift this thing pi over 4 to the left. I'm going to cheat a little bit here. Okay. I'm going to lock this in place, and then I'm going to go ahead and I'm going to change this to plus pi over 4. So I'm going to move this thing pi over 4 to the left. So my zero is going to be here, and my 0 is going to be here, and my 0 is going to be here, and my 0 is going to be here. Okay, and then my asymptotes, I'm going to go ahead and put some asymptotes in here. Okay, normally I would have an asymptote here, but it's going to be shifted pi over 4. So then the next one would be right here, and the next one would be right here, the next one would be here. Okay, and now I'll go ahead and draw, the tangent. Okay, so this would go like this. This would go like this. Something kind of like that right there. Okay, so there is tangent of x plus pi over 4 in orange. Now I'm going to do the -2 tangent. So what's that going to do? That's going to flip this upside down with the negative, and it's going to stretch it with the 2, which I'm just going to approximate. So instead of going up like this is going to actually go this way, and this is going to be much flatter. Go like this. It's going to go like this. And it's going to go like this. It's going to grow much faster, so it's going to be a flatter looking graph. And I'll label that -2 tangent x plus pi over 4. And now I'm done. Okay, 3 secant x plus pi over 2. All right, so this is one secant. I'm going to start with a cosine. Okay, so I'm going to start with a cosine. Cosine looks like this. I'll go ahead and label that cosine. Okay, cosine, let's do the 3. So 3 is going to stretch this thing 3 times. So this is now going to have a key point here, 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 here. I'm going to be hard pressed to fit this on here. Here, key point 0, -3, 0, and 3. Okay, so this is going to look like this. So there's 3 cosine x. Okay, now my next transformation is to move this pi over 2 to the left. So I'm going to cheat a little bit here, take this thing and clone it, and I'll change its color. Okay, and I'm going to move this whole thing pi over 2 to the left, so it would be moved right there. So I need to finish, this is going to go here, and I don't need that part over there, and this is going to be tough. have to redo part of this. So, okay. So then the purple one, this purple one here is going to be 3 cosine x plus pi over 2. Okay. Now, I didn't do myself a favor because this is going to go off the graph. So when I go secant, I'm going to have an asymptote. I'm going to have an asymptote. See, I'm using the purple one. So I'm going to have asymptotes here, and here, and here, and here, and here. Everywhere that this one is 0, I'm going to have an asymptote. And now I can do the secant. So the secant is going to be negative down here. So this is going to go like this. And it's also going to be negative here. And it's going to be positive here. And positive here. So this would be 3 secant x plus pi over 2. So if I'd have been smart and thought ahead a little bit, I probably would have just, instead of stretching this from here to here, I probably would have just changed the scale and made this 3 instead of 1, and then just used the green one instead of the orange one, and then I could have fit my secant on there a lot easier. But that's how I can show my transformations and show that I did my work. Okay, so what do we have here today? Got a little lesson for you, 4-5. It's on tangent, cosecant, and secant, and cotangent. So have fun with that, and I will talk with you next time.